So this is the Unit 0 review sheet, and this is the key for the whole thing. So for number 1, we are just combining like terms. It is important to recognize that there's a plus sign between these two things, between the two sets of parentheses, so we're just going to add the like terms. We start out with negative 5x cubed and positive x cubed, which gives you negative 4x cubed. You do not combine the exponents, you do not add the exponents because we're just adding like terms. Next, 7x squared and 10x squared gives you plus 17x squared. And then negative 8 and negative 2 is negative 10. That is it. That's all you got to do. Number 2. Again, it's very important to recognize that there's a minus sign between these two things. So you're going to distribute the negative sign. You didn't have to do it with a plus sign in the previous problem, but this negative sign you do. So all these terms are going to change signs. It's going to become negative 9x to the fourth, minus x, and plus 2. Now we are just combining like terms again. So we're looking for the 3x to the fourth and negative 9x to the fourth gives you negative 6x to the fourth. Again, you're not combining you're not combining the exponents. You're just combining the like terms, the numbers in front of the variables. Next we have negative 5x to the third, which is going next. There's nothing to combine it with, so we don't. Then we have minus x from right here. And then we have negative 8 and plus 2 gets us negative 6. Now again, just like the last problem, these terms should be in correct order, okay? The largest exponent goes first and then descending from there. And that's our answer. Number 3. Now in this case, number 3, there is no plus or minus between the two sets of parentheses, so now we're going to multiply. All right, please do not multiply if there's a plus or a minus like the last two problems between the sets of parentheses. Okay, so 3x times 2x is 6x squared. 3x times 5 is 15x. Now notice in the 6x squared, because we're multiplying now, we add the exponents between the variables. So x times x is x squared. Negative 7 times 2x is negative 14x. And negative 7 times 5 is negative 35. We combine the like terms to get 6x squared plus x minus 35. Number 4. Here, when we have something that's being squared, we're getting rid of the squared and we're multiplying it by itself. So just rewriting what you have in the parentheses next to it and then multiplying. So 4x times 4x is 16x squared. 4x times negative 3 is negative 12x. Negative 3 times 4x is negative 12x again. And negative 3 times negative 3 is positive 9. Combining the like terms, you get 16x squared minus 24x plus 9. Here, again, we are adding the like terms. There's a plus sign, do not multiply over the plus sign. So we have negative 5x squared and negative 4x squared gives you negative 9x squared. Because we're adding the problems or the like terms together, we're not doing anything with exponents, but leaving them alone. All right, and then 3 plus 2 is 5. Here again, we are subtracting, or just subtracting like terms. We're going to distribute that negative sign to the two terms here to get negative 6x squared and positive 5x. Now we're just combining like terms from there. 4x squared and negative 6x squared is negative 2x squared. Negative 3x plus 5x is positive 2x. And then plus 7 is the last thing. All right. For this set, we have a matching. So let's look at this. Number 7, x squared minus 11x plus 2. Well, no two numbers multiplied to give you positive 2 can add up to give you negative 11. So that's not factorable. So if we look over here on the right, we can see that part C, or letter C, says the expression cannot be factored. So that belongs there. All right. The next thing, number 8, 6x squared minus 12x. Well, I can take a 6 and an x out. I'll be left with x minus 2. So let's check over here. So we've done C. expression can only be factored by a GCF, a greatest common factor of 3x. Well, we did 6x. B is expression can only be factored by GCF of 6. Well, we did 6x. And then D, none of those apply. And number 9. All right, we can take a 3x out of all these terms. We're left with 2x squared plus 3x minus 6. Again, looking at our answers, the expression can only be factored by greatest common factor of 3x. And that is the answer. And lastly, number 10, 60 and 18 share a 6. I'll be left with 10x to the 4th plus 3. And that would give me B. The expression can only be factored by a greatest common factor of 6. And there we go. I'm done with the matching. Here, it says factor each expression completely, so we're just factoring. Two numbers that multiply to be 5 but add to be 6 are 5 and 1. All right, there's no equals 0 at the end of that expression. It's not an equation, so we just have to factor and then we're done. So we have nothing else to do for number 11. Number 12 is the difference of two squares. This problem always gets students. We want to find two numbers that are the same that add up to be 0 but multiply to be negative 64. Negative 8, positive 8. That's it. All right, number 13. First thing I see here is I can take all the numbers are multiples of, they're all even numbers, so I can take at least a 2 out. And all the terms have at least x squared, so I can take x squared out. I'll be left with x squared plus 4x minus 21. All right. I now have to factor what's inside the parentheses. Two numbers that multiply to be negative 21 but add up to be 4 would be 7 and negative 3. I have to put the 2x squared back down because it's still part of my factoring process. And I have x plus 4 and x minus 3. Oh, sorry. I apologize. I put 4. It should be a 7. Now we go. Now I'm good. On to 14. 7x cubed minus 28x. I can take a 7 and an x out of those. Be left with x squared minus 4. Now 14 is very similar to number 12. Inside the parentheses, I have a difference of two squares again. I'm going to put down the 7x. And I need to find two numbers that are the same that multiply to be 4 and add up to be 0 with different signs. Plus 2 and minus 2. A lot of people I keep seeing try 4. Well, 4 times 4 is 16. 4 times 4 does not equal 4. Number 15. Here's a advanced factoring problem. So I'm going to multiply 2 times 3 to get 6. Oops. Two numbers that multiply to be 6 but add up to be 7 will be 6 and 1. I'm going to use the denominator of my first term of 2. And then reduce my fractions. So 6 over 2 is 3 over 1. And 1/2 cannot be reduced. X's go on the bottom, and I bring those to the top. So we have x plus 3 and 2x plus 1. Lastly, 16. Same idea. Take my first term and my last term and multiply them together. So I have 24. Two factors of 24 that add up to be 10. 6 and 4. I'll then use my a coefficient as my denominator. Then reduce the fraction. 6 over 3 is 2 over 1. 4 over 3 cannot be reduced. X's go on the bottom. Bring those to the top. So we have x plus 2, 3x plus 4. And that is some factoring. All right, next, solving using factoring. Now, for some reason, students always struggle with number 17 because they multiply it together. It has already been factored for you. The hard part is over. Take the factors that you're given, set them equal to 0, and solve for x. Please do not multiply this problem together. I will get x is equal to 2/5 and x is equal to -3. So now we're solving. In 18, before I can factor this, I have to get all the terms on the same side. I would like to add 8 to both sides. So I have x squared minus 9x plus 8 equals 0. Got to get it equal to 0 first before you can start factoring. All right, so I need to find two numbers that multiply to be 8 but add up to be -9. That would be -8 and -1. And then take each one of my factors, x minus 8, set it equal to 0, x minus 1, set it equal to 0, and solve for x for both. 8 and 1 would be my answers. Number 19. Oh, down here. So I can take the greatest common factor of 4 out of 4 and 16. I'll be left with x squared minus 4. Now this should remind you of a problem that we did above, right there, number 14. X squared minus 4 shows up again. Again, that's a difference of two squares. I'm going to keep the 4. I have x plus 2 and x minus 2. And they both equal 0. Or everything equals 0. Sorry, forgot that part. Okay. Now, I'm going to take all three of my factors. I'm going to include the 4 in there because it's good habit. And make them all equal 0. So the first part, that doesn't make sense because 4 doesn't equal 0. That's not a true statement, so I can get rid of it. Okay, but I wanted to put it out there because if you take a greatest common factor that has a variable in it, then you do have to make an equation that does work. Okay, the other ones is x can equal -2 and x will equal +2, and then I am done. 20. Now 20 is a little bit tricky. It looks like it's easiest to move the 4 to the right, but in fact, I want to move the other stuff on the right-hand side, the 8x and the -3x squared, to the left. And the reason is because I do not want my x squared term to be negative. So those cancel, and I'm left with 3x squared minus 8x plus 4. Equals 0. Now that my x squared term is positive, it's going to be easier to factor, cause a lot less problems. All right, I'm going to take my first term and my last term and multiply them to get 12. Two terms that multiply to be 12 but add up to be -8, -6, and -2. And then take my first term of 3, use it as my denominator. Reduce my fractions, I get -2 over 1 and -2 over 3. There's my x's, bring those to the top. So I have x minus 2, 3x minus 2, and set them equal to 0. So I have factored, I have to solve now. X minus 2 equals 0, 3x minus 2 equals 0, and solve them both for x. That's it. All right, 21. Two numbers that multiply to be 12 but added to be -8. Would be -6 and -2. Set both of the factors equal to 0. And solve for x. And we're done. '22, again, like we've seen, this is the fourth one, we've seen it. It is a difference of two squares. Two numbers that multiply to be 100 and add up to be 0. -10, +10. We take both of them, set them equal to 0. And solve. X equals 10. And x equals negative 10. There we go. All right. Again, we need to set this equation equal to 0, so we're going to do that by subtracting 6 from both sides. So I will get 2x squared minus 3x minus 14 equals 0. All right. I'm going to take my first term and my last term, multiply them together to get negative 28. Two numbers that multiply to be negative 28 but add up to be negative 3 would be negative 7 and positive 4. Again, I take my first term, my 2, and make it my denominator. Negative 7 over 2 cannot be reduced, so I'm going to leave it alone. 4 over 2 becomes 2 over 1. Put down the x's, bring those terms up to the top. So I have 2x minus 7 and x plus 2 equal to 0. Take my factors and set them equal to 0. And solve for x. So I have x equals 7 over 2. And x equals negative 2. Last factoring problem, solved by factoring. Again, I'm going to add the 2x so I can bring that to the left. Got to put it in the right order. X squared plus 2x minus 15 and set that equal to 0. Got to have it equal to 0 in order to factor it. Two numbers that multiply to be negative 15 but add up to be positive 2 would be positive 5 and negative 3. Set them both equal to 0. And x will equal negative 5 and x will equal positive 3. Okay, next we're doing the functions. So evaluating functions. So we have two functions. We have the g of x function and the h of x function. First one, we're going to put negative 8 into the g function. So I have negative 5 plus, I'm going to put my negative 8 in parentheses, squared. Okay, first thing I have to do is the stuff that's inside the parentheses. So I have 5 minus 8. In essence. So I have negative, still stays there, times negative 3 squared. Next I do negative 3 squared, which gives me positive 9. So now I have negative, Now I have negative times 9, and that gives me negative 9 when I'm done. Next, 26, I put the 3 in the h function. I'm going to put 2 times 3 squared minus 4 times 3. Now you'll notice I'm not putting this in front of the problem. That doesn't belong anywhere. That just tells us the notation that I'm putting 3 into the x values of my h function. Okay, so please don't do that if you had done that in the past. All right. First, I have to do the 3 squared, which gives me 2 times 9, minus, I can also do 4 times 3 to get you 12. All right, then 2 times 9 is going to be 18, minus 12, and 18 minus 12 is 6. Okay, now I'm putting negative 4 into the h function, so I have 2 times negative 4 squared minus 4 times negative 4. Notice I put the negative 4s in parentheses both times to make sure my information is organized. Again, I do the negative 4 squared, which gives you 2 times 16. And negative 4 times negative 4 on the back end here is positive 16. 2 times 16 is 32, plus 16 is 48. And finally, g to the 0. g of 0, so I'm going to go back and figure out what this function is. It's negative 5 plus 0 squared. So it's going to look like this, negative 5 plus 0 squared. Again, I do what's inside the parentheses first, which is going to give me negative 5 plus 0 is 5, and then squared. Next, I do the 5 squared, which gives me negative times 25. My answer is going to be negative 25. Okay. Now for the next section, the last section here, we have to use Desmos. Now in the test, you'll be able to use the testing Desmos. Let's get rid of those. Okay. So the first thing we're going to do is type in these two equations. So we got negative 5x plus 2. And then we're going to make another one of 2x plus 16. Okay, we want to graph these two things on our, sketch the graph of what these look like. Please make them as accurate as possible. You don't have to put down, my pen went away. That's not what I wanted. There we go. All right, sorry about that. They don't, you don't have to put like dash marks to get the exact things, but they do have to look similar to what they're on in Desmos. So it looks like this, it looks like this. All right, my intersection point, which is what we're looking for, we want to find out where they intersect. That's what it says, the point of intersection. If you click on one of the graphs, it points the dot right where they intersect, which is right there, which is negative 2 comma 12. Okay, the next question, same idea. Let me get rid of my points there. I'm going to type in the equations, plus 6, and then 3x plus 1. Okay. So the graphs, again, we're going to sketch those. One looks like this. One is a lot steeper, and it looks like this. Okay. Again, I'm going to touch on one of the graphs to figure out what the point is. Click on the point, and 5 comma 16 is my point of intersection. All right. Next, we're looking for the Y-intercept and the X-intercept, or seps. It could be multiples. We're going to type in our equation. Again, you don't need the y equals. You're just putting in the numbers. So you got 2 minus, just write it exactly what it looks like, x plus 4 squared plus 5x squared plus 8. Oops. Plus 8. There we go. So that's what it should look like. All right. A lot of times the biggest problem students have seemingly with this is they type in the wrong thing and then they base all their information on the wrong graph because they typed in the wrong equation. All right, kind of we want to look at our graph and kind of make it as best as possible. Looks something like that. Okay. So let's look at the y-intercept first. The y-intercept where it crosses the y-axis, which is the one that's vertical, so up and down. So it's right there at 0 comma negative 6. The x-intercept is where the graphs cross the x-axis. There's only 2 of them. That's the first one. So we have 0 up. Negative 0.581 comma 0. And then we have the other one, which is right there. I'm going to put it underneath 2.581 comma 0. And then lastly, we have our last equation. We have 3x minus x minus 1 in parentheses. We're going to square that plus 8x squared minus 5. So our graph now looks like this. It's almost a mirror image of the other one. Looks pretty good. Actually, you know what? I don't like that one. Don't like that. Let's try it again. Don't like it because the vertex is before it hits the y-axis. There we go. That's better. Okay. All right, now we just want, actually want both again. If we want the y-intercept and the x-intercept, let's do the y-intercept first. Zoom in here and hit that point where it crosses the y-axis, which is again 0, -6. And the x-intercepts are going to be where it crosses the x-axis. We have that one at, ooh, that's a long one. -1.3495, 0. And the other one is right there at 0.6352, 0. And that is the review sheet. So hopefully this helped. Good luck on studying and good luck on the test.